everyone, we are from Group 6. I am Sufi Aziz Shazani bin Hafizi, and today we are going to present about 5 case studies of dynamic.
Hi, my name is Muhammad Hafizi bin Rahman. For the topic 1 is a projectile motion of a cannon. Projectile motion refers to the motion of an object that is launched into the air and moved along a curved path under the influence of gravity. One common example often used to illustrate projectile motion is the motion of a cannonball fired from a cannon. When a cannonball is fired from a cannon, it follows a curved trajectory. The key factors that affect the projectile motion of the cannonball are the initial velocity, the launch angle, and the force of gravity. We can break down the projectile motion of a cannonball into a few components. For the first one is horizontal motion. The second, vertical motion. Initial vertical velocity, acceleration due to gravity, vertical displacement, time of flight, maximum height, and range. The actual trajectory of cannonball is a parabolic curve resulting from the combination of its horizontal and vertical motions. The shape of the trajectory depends on the initial velocity and launch angle. A higher initial velocity or a smaller launch angle will result in a longer range, while a higher launch angle will result in a higher maximum height.
Now I would like to talk about curvilinear motion. As example of the curvilinear motion concept is a fan. Basically, curvilinear motion is the movement of an object of particle along a curved path. Actually, this kind of motion can be seen in many situations, like planets moving around the sun, the flight path of the projectile, and or the motion of a car along the curved road. What we can analyze the problem is, firstly, the distance from a point on the blade to the fan's center determines the radius of the circular road. Secondly, the pace at which the fan blades cover angular displacement is represented by their rotational angular velocity. Thirdly, a point on the fan blade that is tangent to the circular road is referred to as having tangential velocity. Next, a centripetal force acts on the fan blades as they travel along the circular path. In addition, there is angular acceleration if the fan blade's angular velocity changes over time. And lastly, the rotation of the fans is impeded by air resistance, so it can also change their speeds and angular velocity. So, for the conclusion in the context of fan, curvilinear motion refers to the spinning of the fan's blades along a circular path. We can know and address the issue relating to this motion by using mathematical equation and physics principle. That's all from me. Thank you.
Bismillahirrahmanirrahim. My name is Muhammad Amalini, and I will talk about force and acceleration in shopping cart. Force and acceleration are fundamental concepts in physics that help us to understand the motion of objects. To illustrate this concept, let's consider the example of a shopping cart. When you push a shopping cart, you apply a force to it. Force is a vector quantity, meaning it has both magnitude and direction. In this case, the force you exert on the cart is directed forward, parallel to the ground, according to the Newton's second law. The acceleration of an object is directly proportional to the net force applied to it and inversely proportional to its mass. So in this case, the problem is the cart requires varying amounts of force to move it. Sometimes it moves smoothly with a little resistance, while sometimes it feels heavier and is harder to push. So the primary opposing force acting on the shopping cart is the friction. Friction occurs between the cart wheels and the floor surface. Factors such as condition of the wheels, type of the floors, and any debris will influence the frictional force. Higher friction will require more force to overcome, leading to the slower acceleration. So how do we solve it? Firstly, we will minimize the static friction. To overcome the static friction, you need to set the cart in the motion that you can apply an initial force with a quick and strong push. This will help to overcome the resistance caused by the static friction and initiate the cart's movement. Next, we need to optimize the surface contact. Choose the smoothest available path while pushing the cart. Look for area with the polished floors or the smooth tiles. This surface will offer the less friction compared to the rough and uneven surface. Avoid carpets or areas with debris that could increase friction. This will help you accelerate your kart. Lastly, you need to minimize the turns and obstacles. Try to navigate the kart in a straight path wherever it possible. Minimizing the need of frequent turns, sharp turns can increase the resistance and make it harder to maintain the acceleration. Avoid obstacles that can cause sudden changes in direction or require extra force to move it. So in conclusion, the interaction between force, acceleration and friction in context of pushing a shopping cart can significantly impact its ease and efficiency of moving the cart. Factors such as static and kinetic friction, wheel condition, surface type, lubrication and weight distribution all play a role in determining the outcome of force and acceleration through the cart.
For the topic 4 is work and energy of weightlifting. Work and energy are fundamental concepts in physics that are often used to analyze and understand the motion and interaction of objects. When it comes to weightlifting, the concept of work and energy play a significant role. Work in physics, work is defined as the transfer of energy that occurs when a force acts upon an object and causes it to move in the direction of the force. Energy is the ability to do work. There are different forms of energy, but in the context of weightlifting, the two primary forms are gravitational potential energy and kinetic energy. When the weight is lowered back down, the potential energy is converted back into kinetic energy as the weight accelerates downwards. If the weight is lowered with control, the potential energy is gradually transformed into kinetic energy and the work done by the force of gravity is negative.
Hi, so I'm going to talk about the linear impulse and momentum of hitting a golf ball. First, linear impulse and momentum play a crucial role in understanding the motion of objects, including the scenario of hitting a golf ball. When a golf ball strikes a stationary golf ball, several physical principles come into play, such as impulse, momentum, and conservation of momentum. A stationary golf ball is struck by a golf club, which applies force to the ball over a predetermined period of time. The ball's momentum changes as a result of the force impulse. The third law of motion by Newton states that the club is likewise subject to an equal or opposing force from the ball. So what's the problem of hitting a ball in linear impulse? Several aspects come into play when looking at the problem backdrop of a linear impulse and momentum in the context of hitting a ball. Understanding these elements is essential to deciphering the physics underlying the ball motion after the impact. One may comprehend the variables affecting linear impulse and momentum in the context of hitting a golf ball. By taking this characteristic in account, understanding the context of the issue enables more true examination of the physics at play and aids in the explanation of the golf balls. So how do we solve the problem? First, we need to calculate the initial momentum to determine the initial momentum of the golf ball. Use its mass and initial velocity for the formula of the momentum. Second, we need to calculate the impact force by taking into the account the force of the golf club makes on the ball during impact. Use that value directly if the force is given. If not, consider the issue and calculate the force using variables like swing speed, impact angle, and the club attributes. Calculate the impulse by multiplying the force of the impact by contact time. Aj equal to the Ft is the formula of the impulse. Next, the system final momentum is equal to the ball's momentum after the contact, since it is considered as the club and the ball's collision is the source of meaningful interaction. And lastly, you need to calculate the shift in momentum, subtracting the starting momentum from the end momentum to determine the change in momentum, equals P final minus P initial, and we get the answer. For the conclusion, a framework for comprehending the motion of a golf club when it is struck by a golf club provided by the concept of linear impulse and momentum. In conclusion, we can forecast the result of hitting golf ball by analyzing the issue and using these ideas. Assuming no external forces are operating on the system, we may anticipate that the total momentum of the system is golfer, club and ball, before the equation will equal to the total momentum of the hit after the hit based on the conservation of momentum. The force of the golf club will produce an impulse that will alter the ball's motion, the mass, the speed and the length of club's contact, as well as outside variables like friction and air resistance will all have an impact of the golf ball final motion. A change in momentum will cause a change in the ball's velocity and direction.